Welcome back, chemists. In our first video on significant figures, we focused on how to identify the number of significant figures in a number. Now we are going to focus on how to manipulate our data and have the correct number of significant figures after the result of calculations. And so after this video, you should be able to apply the rules of significant figures in calculations and perform calculations involving multiplication, division, addition, and subtraction, and then round your answers to the appropriate number of sig figs as well as include the correct units. So when we talk about significant figures in calculations, we split it up into two major categories. The first rule deals with addition and subtraction. So the main idea with addition and subtraction is that you want to look at the decimal places. Your answer is then rounded to the same number of decimal places as the number used in the calculation with the least decimal places. Whew, I know that sounds kind of weird, but what you're going to be doing is when you're performing addition and subtraction, you're going to be looking for the least number of decimal places in the numbers that you're subtracting or adding. So for example, I've got two examples here. In the first example, notice it's 5.7 plus 2.11. The number 5.7, the 0.7 indicates one decimal place to the right. So that means your answer is going to reflect one decimal place to the right. In the second example, you have 7.12 minus 1.345. In the number 7.12, 0.12 has the smallest amount of decimal places. So therefore your answer is going to have two decimal places. So when you look at these numbers, notice that in the first answer you get 7.81, and based off of the 5.7, you should have one decimal place to the right. In the second answer, you get 5.775, but again, based on the 7.12, your answer only needs to have two decimal places to the right. In terms of rounding, if it's a 1 to 4, then you're going to just chop the number off. So in the case of 7.81, this would be just plain old 7.8 meters. In the number 5.775, notice that there's a 5 next to the 7. So that's going to round the 7 up so that your answer should be 5.78 grams. Notice I did bring the units down, and you want to make sure that you bring the units down as well. Here are some other examples. So in this example, I have 4.00 minus 0.230. So notice that my answer again needs to reflect the least number of decimal places. So I'm going to make sure that my answer only has two decimal places to the right, and so I should end up with 3.77. In the next example, I have one number that has one decimal place to the right, so therefore my answer, when rounded appropriately, should have only one decimal place to the right. In this next example, I have 2.0, which again has one decimal place to the right, versus the other number, 100.45 milliliters, that has two decimal places. My answer again has to have one decimal place to the right. Just be careful here, there's a 5 next to the 4, so therefore that 4 is going to round up to a 5. So your answer is 98.5 milliliters. In this one, we are adding multiple numbers, but you still handle it the same exact way. So the first one has two decimal places to the right, the second one has one decimal place to the right, and the third one has three decimal places to the right. So that means your answer should only have one decimal place to the right because that's the least, and so therefore it should be 11.4 centimeters. Let's talk about multiplication and division. So with multiplication and division, you're going to be looking at the total number of significant figures in the numbers that you're multiplying or dividing. And the answer is going to be rounded to the same number of sig figs as the number used in the calculation with the least significant figures. So for this one, you're not focused on decimal places anymore. You're focused on the number of sig figs in the entire number. So for example, if I had the first one on the left, notice it's 17.85 grams divided by 2.13 milliliters. So we're not concerned with decimal places here. We want to look at the entire number. So the 17.85 has 4 sig figs, the 2.13 has 3 sig figs. That means our answer needs to reflect 3 significant figures. Notice also how it's grams over milliliters because you're dividing, right? Grams over milliliters does not divide out, so you want to make sure that you take them along for the ride when you write your units. If we look at the next example, notice that we have numbers with leading zeros in them. So even though it's 0.0561, that only has 3 sig figs. And 0.030, be careful here, you actually have a mix of leading and trailing zeros. So the 3 and the 0 at the end there is significant. So because there's 2 sig figs in the bottom number and 3 sig figs in the top, that means, right, 2 is the lesser of the 2 numbers, so therefore your answer needs to have 2 sig figs. And so therefore, when you round appropriately, you should end up with 0.0017 centimeters squared. And the reason why the centimeters are squared is because you multiplied centimeters times centimeters. Okay, so let's try some examples with this. So we've got this first one. Notice there's 1 sig fig with 4, and so then our answer should only have 1 sig fig. So it would be 9 centimeters squared. 5.0 over 7.77, right? There's 2 sig figs in the first number, 3 in the second, so therefore our answer should only have 2. And then for the third example here, 0.0045, remember those zeros are leading. So there's 2 sig figs with the 4.5, and there's 3 sig figs for the 2.05, so therefore our answer has to have 2 sig figs, and so therefore it would be 0.0092 milliliters squared. And then finally, notice we're multiplying 3 numbers, but again, you handle it the same exact way. You're going to just multiply everything, and your answer is going to reflect the least number of significant figures, and in this case, that would be 2. So 0.54 centimeters cubed would be the answer here. So one question that I get a lot from students is what happens when you have more than one calculation to perform, right? Like maybe you've got a mix of calculations. So here's an example of that. So notice I've got subtraction in the first step and I've got multiplication in the second. So what you want to do when you do something like this is you do not want to round at every step. You're going to keep the numbers in your calculator and retain full calculator accuracy throughout the entire calculation and round according to the number of sig figs in the original data. So you want to round essentially at the end so that you don't introduce any rounding error. So if I were to do this calculation right now, what I would do on my calculator, I would type in 320 minus 22.7, and I would write my answer above it. So I get 297.3. Now if you notice, I put in red 297. The reason why I did that is because if we're looking at subtraction, remember the number of decimal places tells us how many sig figs there should be in our answer. So I put in red 297 because technically our answer shouldn't have any decimal places based on the fact that the number 320 doesn't have any decimal places. Now obviously you might not have a red pen near you when you're doing your homework or working on a test or a quiz. So one thing that you could do is you could potentially put check marks over all the numbers that are significant, and that will help you keep track of them that way too. And then after I do that, I'm going to multiply that 297.3 and I'm going to multiply that by 3.8. Remember, don't drop that 0.3. You want to keep the whole number. And then when you do that, you should end up with your answer that looks something like that. Now, the reason why I put the 1 in red is because when you switch rules and you're going to multiplication, notice we're concerned with the least number of significant figures, right? We're not looking at decimal places here. So we've got the 297 from the first rule, which has 3 sig figs. We've got the 3.8 from the second rule, the second calculation, which only has 2. So that means our answer should only have 2 significant figures. And so therefore, 1100 centimeters squared should be the answer. Here's another example calculation that you would encounter, and this is an honors level type of question where it's a word problem, and you're expected to adhere to all your sig figs. So you might want to pause the video and try to work this out on your own, and then I'll walk you through the example. Okay, hopefully you tried it on your own. One of the things that I love to do whenever I am given a word problem is I like to draw pictures. This is a strategy that I use. You don't have to do it, but I find that it really helps me. So the first thing that I would do is I would draw a picture of a flask, and I would show that I put the little stopper in the flask. And then what I do is I label everything from the problem. So for example, I show that there's a mass of the flask of 87.432 grams before, and then after I add 34.4 grams of liquid, and that volume is 57.69 milliliters. And then after, the data I have is that the mass of the contents is 146.72 grams, and now the volume occupied is 234.5 milliliters. Now my goal is to decide what is the density of the rubber stopper. So another thing that I do is I write out the density equation, but I'm specific. So I write, for example, if I want the density of the stopper, that means that I need to find the mass of the stopper and the volume of the stopper. So I need to focus on that in order to get that information. So the first thing I'm going to do is get the mass of the stopper. So I know that I can get the mass of the stopper because I know that the contents after the total mass was 146.72 grams, whereas the mass of the liquid by itself was 34.4 grams and the mass of the flask by itself was 87.432 grams. So if I subtract those two numbers from 146.72 grams, I want to make sure I have proper sig figs. Notice that we're subtracting. So the 34.4 grams is going to limit the number of sig figs because I only have one decimal place to the right. So therefore my answer should be 24.8. Now, again, I wrote out the rest of the digits because you want to round at the end. You don't want to incorporate rounding error. So just like that, I was able to find the mass of the stopper, but I indicated how many sig figs there should be in my answer technically, even though I'm not going to use that rounded number in the calculation. So let's get the volume of the stopper. That's up next. So to get the volume of the stopper, I am going to do the 234.5 milliliters that the stopper and the liquid occupy, minus just the volume of the liquid, which is 57.69 milliliters. So when I subtract those two, again, I want to pay attention to sig figs. My answer is only going to have one decimal place to the right. So therefore my answer is going to be 176.8. And then I included the 1 there because, again, I want to maintain full calculator accuracy. So then my last step is to take the mass and the volume and divide the two according to the equation. And again, I want to make sure I use the entire number and not the rounded numbers. So it's going to look something like that. And then when I do my division, you do want to watch out here. We're changing rules here. So notice there's 3 sig figs on the top and there's 4 on the bottom technically. So that means my answer needs to reflect those 3 significant figures. And then my units are grams per milliliter because, again, those do not divide out. All right, so I imagine that you're going to definitely have questions on this. And this stuff just takes practice. So make sure you take your time, do your homework, check your answers, and I know you'll do great, chemists. Thank you so much for watching.